Hello, this is another quick answers on MQL4 and today I'm looking at using templates. This is not templates as in sections of code that are already written where you just replace a few values. This is the template keyword inside the MQL language and it's in response to questions about being able to create generic functions. So I've created a script that uses templates and it's here on screen now. I'm starting out with a string array and an integer array and a double array, and I'm just filling those with some random strings, a broken Fibonacci sequence, and some of my favorite numbers, pi, e, and phi. Then I'm printing the values of those arrays. Before insert, I'm printing the string array, and here I'm calling a custom function called array_to_string, passing in the string array. I have the same function name passing in an integer and the same function name passing a double. I could simply have created three versions of the array_to_string function, and using overloading it would take the arguments string, int, or double. But then in future, if I wanted to add something like a date, time, or any other value type, I'd need to create even more copies of this function. So what I've done instead is use the template keyword. And here it is, template. Template followed by the left angle bracket or less than sign, type name, T is just a placeholder, and then the right angle bracket or greater than sign. What this tells me, or what this tells the application, is that any time that it sees T, it replaces that with a type name, whether it be string, integer, double, and it gets the type name from the arguments passed into the function here. So you can see I'm also declaring an array of type T. So if this is an integer array, then any place that T appears, it will look like int. And if this is a double array, any place that T appears, it will look like double. So I'm returning a string in the array_to_string function, passing in an array of realistically any type. I do have a default separator which defaulting to an underscore. And then all I'm doing is concatenating all the values in that array together. So starting out with nothing, calculating the size of the array, and then looping through the values, concatenating. And this line simply removes the trailing separator which would have been added, and then I return the result. So this code would be the same regardless of any of the primitive variable types. And if I had used overloading, I would be duplicating this code 3 times at least to handle strings, integers, and doubles, and then duplicating further. But by using the template, I was able to write this function once, and it will work for any of those types. I could pass anything in the array, but there may be some variable types that string concatenate function doesn't work with. So this is close but not perfect, and the only flaw in this is the ability to just use string concatenate. So if you passed an object in here, that may not work. So let's go back to earlier place. So that's the 3 array_to_strings, and that will print concatenated strings showing the values in these arrays. Then I want to insert values into the arrays. So I'm going to insert into the string array. I'm going to insert the value hello at position number 2. And counting from 0, 0, 1, that will insert hello just before rosebud. I'm going to call array insert on the integer array, inserting the number 5 at position number 2, which will fix my broken Fibonacci sequence. And then I'm going to insert into the double array the square root of 2 between pi and e. Now array insert is another custom function, and I'll go to the definition here. Again, template, type name, T is just a placeholder. There's no return value, so this is a void function. Array insert, type T of the array, and here I'm also saying the type T must be the same for the value being passed in, and the index number where I'm going to insert this value. This line simply checks that the index is a valid number, and if it's not, then it will make it the end of the array. I'm simply extending the array by 1 and then looping through from the end of the array, counting down using I minus minus until I get to index, and dragging all the values in the array up by 1, and then I'm simply setting the index value in the array. As before, all of this code would be the same regardless of the data type being passed in, but because I have to declare the data type in the function declaration, I'm able to do this once using the template keyword. And here you can see value has to be the same type as the array. Let me just go back quickly. First I'll compile this to demonstrate 0 errors. It all compiles. If I add array insert of the double array, and if I insert a string, and then I try to compile this, I now have an error that says template parameter ambiguous, could be double or string, because it's trying to match the type double to the first argument and the type string to the second argument, where I've declared that they should be the same. So I'll just remove that now and compile again. After the array insert, I'm again using the print with the array to string, and then I'm going to use another function, array remove, to take, I'm going to remove the XYZ from the string array, removing 13 from the Fibonacci array, and I'm going to remove pi from the double array. This function actually has a return value. I'm returning the value of the element that has been removed. So let's have a look at this. Again, template, type name T, and here the function type is of type T, which is the value being returned. Array remove, array of type T, and the index number. And the code here isn't very important, but you can see I've also used T inside the function to declare result of type T. And I'm able to pull out the indexed value from the array there, and then I'm simply removing that element from the array by shuffling everything and eventually resizing the array, and then I just return result. And finally, after I've done that remove, I'm again doing a print statement. After remove, I'm showing the string array, and here I'm also saying after removing and the value that I removed. So the removed string, integer to string of the removed int, and double to string for the removed double. So if I run this, then we can switch over to the chart and see what, compile and run. If I go over to my terminal, script initialized, before insert, and we can see that before insert the string array was ABCXYZ Rosebud, the integer array was 23813, and the double array was pi e phi. After doing the insert, we can see that hello has been inserted into the string array, 5 has been inserted into the Fibonacci, and the square root of 2 in between pi and e. Then after the remove, you can see that the XYZ has gone from the string array, 13 has been removed from the end of the integer array, and pi has been removed from the beginning of the double array. So, quick explanation there of how you can use templates to create generic functions. These are simple applications. You probably won't use templates very often, but when you get to a situation where they can be used, they will save you quite a lot of time and make your code much cleaner and remove the need for duplication. I hope this has been useful to you. I will also be talking further about templating in the upcoming video, where I'm enhancing the dashboard that we've been creating in the object-oriented development series. So please, if you want to see that, or if you want to see other videos in this series, remember to click the subscribe and the bell icon to be notified when we release more videos.